Hello, Assalamualaikum. Today we are going to continue with our lecture. So, we are going to enter a new chapter, which is chapter 10. The title of this chapter is Introduction to Ordinary Differential Equations. So the short form is ODE. So, before we go into the ordinary differential equations topic, so let me recap what is the mathematical equations category. So mathematical equations can be categorized into three different types. First one is the differential equation right here, and the second one is integral equation, right? So, and the last one is integral differential equation. So for differential equation, we have learned about this, dy, dx, dz, dx, and so on. Okay, and for integral equation, we will have this symbol. This is the integral symbol. And the last one is the combination of the differential equation and also the integral equations components. And when we combine it, we will have the integral differential equation. Okay. Now we go to the one application of or one problem that we can use ODE to solve the problem. So this is an aeroplane in the airport. So we have the freeway, and in this problem we want to know what is the length of the freeway that is suitable for this aeroplane to take off. So we need to consider all forces involved in this problem. So let's say this is the center of the gravity, and the forces that involve is, first of all, the weight. So this is the weight, which is mg. M is the mass, g is the gravity, and we will have the reaction force. The reaction force will be at the wheel. So we combine the reaction force for all wheels, and we write down here. So we can denote it as G, and also we will have the thrust. The thrust is from the engine, from the turbo engine. So we will have the thrust to the front. So this force will pull the aeroplane or push the aeroplane to the front. And from this thrust, from the aerofoil, we will have the lift force. And due to the motion to the front, we will have the resistance. The first one is the drag, and the second one is the friction. So we put it as R. Okay, so this is the components, the forces involved when an airplane is taking off. Okay, so we can have equation from this free body diagram. So we consider the vertical components. So L plus G is equal to mg. Okay, right. So when we consider the vertical component, we have the lift force, the reaction force, and also the weight. And when we consider the horizontal components, we will have T minus D minus R equal to M. Yeah, we need to consider the mass, and the acceleration, ds dt. Actually we have a square right here and right here. Okay, so that is the acceleration. So as we know, each of these component has their own equation. For example, the lift, the drag, the reaction or the friction force. So we can elaborate that. So L is equal to alpha V squared. So V is the speed, and I forgot to say that S is the displacement. S right here is the displacement. Okay. And we can elaborate the drag equation. So drag is equal to beta. So beta is the properties of the aeroplane, and V. So if you look at here, the lift force is depend on the speed, the drag is also depend on the speed, and the last one is R. So we can consider the right some of the component in this case. So the third component is R, which is the friction force. So we have the friction coefficient m mu, and we multiply with the g. G is the reaction force. Okay. So when we replace these three into the main equation, which is this one, so what will happen is we will have m I can write here m problem with this. Okay, m d square s dt square. Okay, this one, this component, minus mu alpha minus beta. So this is the coefficient, and multiply with speed plus mu mg, and this is equal to T. Okay, where T is the thrust. And then by replacing V, which is the speed, by, let's say we replace the V equal to ds dt. Now we will have m d2s dt2 minus mu alpha minus beta, and we have ds dt square plus or equal to T minus mu mg. Alright, so I think we can stop right there, and we assume that this is the equation for this problem, and we can further investigate what is the equation of T, what is the equation even for the mass, because the mass is depend on the shape of the aeroplane, but we don't want to go into detail. But what I want to show is we can have this ordinary differential equation. What I mean by ordinary differential equation is we only have one independent variable, which is what? Which is t. So the independent variable is t, and the dependent can be more than one. For ODE, the dependent can be more than one, but in this case we only have one, which is s. So s is the displacement. So when we solve this equation, we can have the answer. We can know what is the length of the freeway, which is the value of this s. Okay, so that is one example. Actually, there are other example in the book. You can go to subtopic 10.2.2 domestic hot water supply. You can learn that other different cases can also be solved by using ODE. Similar to 10.2.3, where hydroelectric power generation is the problem. 10.2.4 is the simple electrical circuit problem. So now we can skip that, and you can learn that by yourself. It's a good experience if you can read them all. So we go to the next subtopic, which is 10.3. 10.3. 10.3 is the classification of ODE. Okay. So ODE, ODE can be classified. There are many classifications for ODE. The first classification in this subtopic is it can be we can have the independent and dependent variable. Like I said just now, inside the ODE we can have inside ODE we will have two type of variables, which is independent and dependent variables. Okay, so let's go straight to the example, the first example for this chapter. So example 10.1. So the given equation is d square f dx square minus 4x df dx equal to cos 2x. Okay, so what is the independent variable? So I can simplify. I can just write IV, and for the dependent variable it can be dV. Okay, so IV is x. So when you look at the component, whenever at the bottom there is the independent variable usually, and the dependent variable is at the top. Okay, so dV is f. Okay, when we consider the other two equation, which is correlated, in the same example. So for dx dt plus 3 dy dt minus x plus 2y equal to cos t. Okay, and another equation is 6 dx dt plus minus 2 dy dt minus 2x plus y equal to 2 sine t. Okay, do you know what is the IV, what is the independent variable, and what is the dependent variable? If you look at here, there are 3 variables in this case. So like I said, whenever when there's fraction of the derivative, the bottom is usually the independent variable. So we know that t is the independent variable, and the dependent variable is these two, so which is x and y. Okay, is this a partial derivative or normal derivative, or partial or ordinary? Because we look at the top. Oh, I forgot to mention. So okay, before we because I missed that part, so I explain right now. So for mathematical equation, okay, for differential equation, I forgot about this. Differential equation, it can be divided into 2 types. First is ODE, the one that I explained just now, and the PDE, the one that we have learned in previous lecture. So for PDE, what the difference is, PDE it can have more, not it can have, but it have more than one independent independent variables. Okay, remember, this is independent variable. And for ODE, it should have only one independent variables. Only one, more than one. Okay, so you need to remember this. So in this the equation that I shown you just now, if you can see, the independent variable we only have one independent variable, but the dependent variable can be more than one. It can be one. If it is one, it is still ordinary differential equation, but it is, when it is more, it's still ordinary differential equation. Okay, in this case we have two dependent variable. I don't want to make you confused, so I make this one color red. Okay, so remember these concepts. Okay, now hopefully you understand the difference between ODE and PDE. And this three equation is the example of ODE. Okay, now we go to the second categories, characteristic on not characteristics, classifications. Second classification of ODE. So ODE also can. Sorry again. ODE can be categorized into different order. So this is the derivative. So we can have first derivative, second derivative, third derivative, and so on. So we go to example 10.2. Okay. Okay, we don't have to go to the example 10.2 because actually we use the same equation with example 1. So example 10.2 is based on equation in example 10.1. So now from this equation, may I erase this color so that you can see clearly. Okay, so for the first equation, this is the second order. Why? Because we look at the highest order of derivative. So in this equation, we look at the derivative. This is the highest order, so it is 2. So we say that it is the second order ODE. And for this second and the third equation, so we say that the order is the first order. Why? Because again we look at the derivative. The highest order is only first derivative. So we say the ODE is the first order. Okay, simple. So we go to the next classification. The next one is 10.3.3. So we want to see whether it is linear or non-linear. So how to differentiate this? Okay, we go straight to the example 10.3. Okay. So I think it's better for me to write down again so that you can see it clearly. So actually they are using the same equation, but I just write it down again, bigger this time so that you can see clearly. For x dx equal to cos 2x. So this is the first equation. and the couple equation, the two, the second and the third equation, for dx dt plus 3dy dt minus x plus 2y equal to cos t. Okay, so the last equation is 6dx dt minus 2dy dt minus 2x plus y equal to 2 sin t. Okay, so okay, all of this equation, this equation 1, equation 2 and equation 3, all of them are linear or just ODE. Okay, all of these are linear ODE. Okay, now I will write down what is the non-linear ODE, and after that we can compare the difference between the two. Dx dt square plus 4dx dt equal to 0. Okay, this is the first one. d2 x dt2 plus x dx dt equal to 4 sin t. Right, and the last one, 4 dx dt plus sin x equal to 0. Okay, this all is non-linear ODE. Okay, why? This one is all of this is non-linear. Where I can put this one? Okay, so why? Because for the first one, the derivative is square. So if you look at here, this derivative is squared, and that's why it becomes nonlinear. Okay, and for the second equation, because of the product of dependent variable and its derivative. So it's right here. So this is the dependent variable and this is its derivative. So when we have this kind of product, the equation will be nonlinear. And for the last one, okay, the last one is because of this component. the non-linear function sine x of the dependent variable. So sine is the non-linear function. So when sine is used for the dependent, as dependent variable, so it will become nonlinear. Okay. Alright. So hopefully you get some idea about what is the difference between linear and nonlinear equations. And now we go to the next classification. The next classification is in subtopic 10.3.4, homogeneous and non-homogeneous equation. Okay, so what is the difference between homogeneous equation and non-homogeneous equation? So we go straight to the example 10.4 to see the difference. So the given equation dx dt plus 4x equal to 0. Okay. The second one is 4 dx dt plus sine t times x equal to 0. Okay. These two equations is both homogeneous. ODE. Remember, this is a classification of ODE. And for the next two equation, d2x, I will show you the non-homogeneous. dt2 plus t dx dt equal to 4 sine t, and d2f, so this is different equation, minus 4x df dx equal to cos 2x. So this is non-homogeneous ODE. Okay, and you see the difference. So if you look at the previous equations, if you look at here, for example, this three equation 1, 2, 3, if you look closely, you can see that there is no dependent variable at the right hand side. If you look at here also, there is no dependent variable at the right hand side. This one also the same. No dependent variable at the right hand side. Okay, no dependent variable at the right hand side. So that is the arrangement, the standard arrangement when we want to write down ODE. So when we put all the dependent variable at the left hand side, and when it is equal to 0, we call it homogeneous ODE. So when we have something at the right hand side, whether it's constant or we have the independent variable, for example this t and this x. So don't get confused with this equation and this equation, because the x is for the first equation right here is the dependent variable, but for the second one x is independent variable. So when independent variable is at the left hand side is fine, but the dependent variable should be at the left hand side. Okay, so when there's something at the left hand side right here, or a constant, so it will be non-homogeneous ODE. Okay, so that's the category. And if we want to know further what is the difference between homogeneous, non-homogeneous, linear, non-linear, what is the use of the linear, non-linear, and so on, you can learn it by yourself. So for now, you just need to differentiate and know the classification of the ODE. Alright. So that's that's the finish of the subtopic. Now we can go to the next subtopic.